Okay, guys, so here we are back at section 8.5. We're looking at part two, and we were dealing with this situation here where we were well, basically, we were trying to solve this equation here. So, this equation is what we ended up getting after taking this relationship, solving for x in this relationship here and then substituting here. All right, so that's a quick recap of what happened and now how to solve this. So there's a lot of work to be done. The fact of the matter is, I don't really feel like carrying around decimals. Like the tangent of 26 is some decimal number and the tangent of 70 is some decimal number. I could multiply it and do my thing and kind of work through it. But what I'm going to do is try to work as hard as I can to make this problem calculator ready. So watch, all of this is algebra stuff you know, but maybe algebra stuff you don't remember or you haven't exercised in a while. So please follow along with me so we can talk. So remember, our goal is to solve this. We're trying to get y by itself. Then after we get y, we'll go back in. We'll substitute for x. We'll substitute for y, calculate what x is, and we'll be done. All right. Ooh, a lot of work, but we're tough. So tangent of 26 is equal to this. I'm going to multiply both sides by 10y. I keep saying that, or 10 plus y rather, right? And so what I'm going to do is cancel out the 10y in the denominator. And now my equation is 10 plus y quantity times the tangent of 26 rather, is equal to y times the tangent of 70. And so what I'm going to do now is use the distributive property, 10 tangent 26 plus y tangent 26 is equal to y tangent 70. Our goal is to solve for y, so we're going to get our y terms over to one side. We're going to get our y terms over to one side. So notice that this is a y term and this is a y term. And to move it, remember to move any term. Remember, this is just a number. So this could be like 7y, right? To move something like that, you do the opposite. So I'm going to do the opposite of tangent of y tangent 26. And I'm going to subtract y tan 26 on this side as well. Okay? And then so what I'm left with is 10 times the tangent of 26 is equal to y times, okay, y tan 70 minus y tan 26. Okay. Now what I'm going to do is the reverse distributive property or factoring. I keep forgetting you guys are like algebra professionals. You're going to factor out the y. So we're going to, and I like to call it reverse distributive property because look, when I do this, I don't need that y there anymore. When I do this, putting the y out here informs that I'm supposed to distribute it through. Remember, my goal, guys, is to isolate y and make this problem calculator ready. So I'm doing a whole lot of stuff to get y by itself. So all I have to do is go to Desmos or whatever calculator I'm using, plug the information in, and I'll be able to get the answer. So just stay with me. A few more moments. So now I'm going to divide both sides by this thing here, tangent 70 minus tangent 26. And this way I'm isolating my y, right? And so now I do know what y is and I am calculator ready. So y is equal to, I'm just changing the side just so it's easy for me to write, y is equal to 10 times the tangent of 26 divided by tangent of 70 minus tangent of 26. If you have a sweeter way of doing this, let me know, but I thought that was pretty sweet personally. So I'm going to go over here to Desmos and write down the information I need to. Let me see if I can remember what it is I was supposed to type in here. So we're trying to do, let me go over here again, scooch this over. Thank you guys for letting me work on my ability to use technology. All right, so y is equal to 10 tangent of 26, and I'm going to divide that whole thing by the quantity of, and let me put parentheses around it, sometimes that helps, tangent of 70 minus tangent of 26. And now that I have all that information in there, I get an unremarkable number, but a number nonetheless. That is 2.15, or if I'll round it to the nearest hundredth of a meter, I think we were dealing with, it is 2.16 meters. So let's get back to our original problem. Let's get back to our original problem over here. Let me make this a little bit bigger. Remembering that y is equal to approximately 2.16 meters. Have you forgotten what we're fighting for? I've forgotten. Let's go back and see what this picture was about. Oh, I see, I see. This y is 2.16 meters. And what about the x value? How are we going to do that? We don't have to come up with a whole new problem. We have the information here to solve. Remember, 2.16, that y value times the tangent of 70 is going to give us x. Woohoo! So let's go back over to Desmos, our good friend. Hello, Desmos. And we're going to come over here. Actually, okay, I won't be extra math lady right now. 216, I'm going to multiply that times the tangent of 70, and then I get 5.934, which will round to 5.93. Let's go back over here. So x is equal to 5.93. You see we did that. X is equal to 5.93. So 5.93 is the value of x. But we are not done. Remember, we're supposed to find out how tall the tree is to the nearest meter. We got to add Mrs. Long's height because she's 1.7. So the tree, drum roll at home right now, children. Drum roll, you must. 5.93 plus 1.7. And with a little bit of, I could use a calculator, but you know what? This is just an awesome day. 6, carry my 1, 5, 1, 7, 7.63 meters is the height of the tree. Are you guys impressed? Okay, probably not, but that's okay. It was still awesome doing the work with you. And when you do math like that, it's like having a good workout. It's like, yes, I can do the stuff. So you should feel proud of yourself if you were able to follow along. If you weren't, that doesn't mean you shouldn't feel proud of yourself. It just means we need to talk about it again because I didn't do a good enough job explaining it to you. So make sure you let me know if we need to talk about it again. I look forward to talking to you and seeing you soon. Please take care. Bye-bye.